If you have any questions at all about visibility, I think some of you might have been getting it backwards. Remember when you start array and you go into the next view, whatever you hit first is what's on top in the view that you started your array from. So I think a lot of you are projecting to the next view. Whatever it hits first, you're putting that one on top in that view. So it's always back to the view that you started on. And that's going to continue to be important because today we're going to talk about the intersections of lines and planes, and then next time we'll talk about the intersection of multiple planes, and you'll be needing to determine the visibility for each of these items as well. So let's start with a little example here. Let's say that I've got a triangular shaped plane, and it's an oblique plane of some angle, and it has line AB piercing through it. So the first thing I want to know is, where does it actually intersect? So the rule that we'll start with today, probably not going to be much of a surprise to you, is we want to find the edge view of the plane. So if I can find the edge view of the plane, then I can find that intersection point where they cross over each other. And then I can project it back into the other views. But then, after I've got the intersection figured out, I'm going to have to solve for visibility, because if the line runs along this vector and it goes through that hole, does it show up like this, where you can see the line right here and you see the plane here? Or does it actually flip back this way, where you see the line and you see the plane here? So we're going to have to solve for visibility just like we did when we had two pipes. So let's take a look at that in my slides and then also AutoCAD. Okay, so like I said, the principle of the day is we're going to find the edge view of the plane, and then that will help us find the intersections. So if I take a look at this example here, sometimes on my exercises you'll see it like this, where the line isn't completed and you have to join it together to make one continuous line. Part of that is because some of these exercises actually come from the board drafting days, so you couldn't just erase a line that the book drew in for you, so you had to complete the line first and then trim out what you don't have. So here I've got line GH that pierces plane ABC, and I want to know exactly where that is. So in order to do that, I need to find an edge view of this plane. And again, the steps to do that is I need to find a true length line on this plane so that I can then find the point view. So I'm going to create in the front view a horizontal strike line and project that up, and then show my true length strike line in the horizontal plane here. Then I can go ahead and create my hinge perpendicular to that true length line, and then I can bring all my points across. And again, I'd recommend you do them at least one at a time, if not do the line and do the plane separately, so that you don't get confused. But after bringing all those points over, A, B, and C should line up in one straight line and give me an edge view, and then I should have the line crossing over it. So that now gives me my point of intersection that I can project back. So I'll project this point back, and that shows me where the intersection is on this line. I can then take that point and project down to find where the intersection is in the front view. So Dami, why don't you pay attention to this instead of working on the stuff from last time, all right? So once I have my intersection point, then I need to solve for visibility. So to solve for visibility, let me see which view this one starts with. Okay, it looks like it's solving the top view first. Okay, so to solve for visibility, what I want to do is I want to take one of these two apparent intersections. And what I mean by apparent intersection is that they don't actually touch. This line doesn't actually touch this plane here. It's an apparent intersection. The only place they really intersect is right here. So same thing right here. This is an apparent intersection where they would cross over. So I want to take one of those two. Doesn't matter which one. I'm going to take one of those two, and then I'm going to draw a ray into the next view, just like we did with the pipes. So let's say I take this one. I'm going to project it down. Whatever it hits first, and this is important, it either hits the line first, or it hits not just the plane, but edge AB of the plane. So what does it hit first? It hits the line first. So that means the line is on top, back here where I started my ray, in between this apparent intersection and the insertion point. So the line is on top right here, which means I'm going to trim out the opposite. The plane is on top here. So that would be the correct visibility of that one. And again, just to double check myself, you don't have to do them both ways, but just to double check myself, I'm going to take this other apparent intersection. Does it hit edge AC or GH first? We would expect it to hit AC first, right? Because I've said the plane is on top on this side. So as I come down, sure enough, it hits edge AC first, so the plane is on top. So then to solve the front view, once again, I'll take one of these two apparent intersections, let's say this one, and project up. Does it hit GH first or plane edge BC first? It hits BC first, so that means the plane is on top between the pierce point and this apparent intersection. So I'll trim out this portion. And again, just to double check myself, AC versus GH, I project up, and see, here's where you gotta make sure you pay attention and not just say, okay, it hits the plane first, so the plane's on top. This is edge AB. I'm looking at edge AC. So as I come up, it hits the line before it hits edge AC. So that means the line is on top on that side. So we're also going to take a look at a second method of figuring this out, and it's actually kind of a quicker method. So on today's assignments, you've got one where you're doing the edge view method and one where you're doing the cutting plane method. So just please use the method that you're asked to use on each of these. The cutting plane method is actually a little easier, and it actually alludes to what we're going to do next time, which is, excuse me, find the intersection of two planes. And as you may have guessed, to find the intersection of two planes, we want to show one of those two planes in edge view. So we'll talk more about that on Wednesday, but in order to do this today, what we're basically going to do is we're going to pretend that this is not a line, it's actually the edge view of another plane. And if it was an edge view of another plane, then that means these are no longer apparent intersections, they actually potentially intersect, so I can project these into the next view. So where this line or pretending edge view of a plane intersects AC, I can project that down to AC. Where this intersects with AB, I can project that down to AB. I can then draw in this line, and that is my intersecting line. That's my pierce point right there, which I can then take that up and show my pierce point there. Yeah, a lot easier. And then I just solve for visibility, which isn't going to change from when we did this just a few minutes ago. So that one's a much quicker method, but we'll do, again, one drawing today where we'll do edge view methods and another one where you do the cutting plane method, and it goes a little quicker. And that'll help you get ready for next time when we're actually doing planes. So let's take a look at an example or two in AutoCAD. As always, I've got some sample files. So I'm going to go to New and Templates, Additional Files, and then Intersection Practice. So intersection planes we'll do next time, but intersection practice for now. So as I take a look at these first two, I'm setting this up as the edge view method. And here's the first thing I would suggest you do. If you open up one of these drawings and I've got the lines drawn like this where they're not connected and you're going to have to finish them out, instead of drawing an extra line in between them, I would recommend using the join command. You can type J for join, or you can use the modify drop down here, and these two arrows pointing up against each other is join. And if you pick on two collinear lines and press enter, it will turn them into one line. So I can't recall on the exercises if I did that for you already. If not, just go ahead and J for join and join those together. So step one, I need to find a true length line on one of these planes. It doesn't look like I have any true length edges, so I'm going to have to create my own. So I'll start down here in the front view at AF and draw horizontally over to BC. And I can now project that point up to BC in the horizontal view, and then back to A. And that'll be my true length strike line. And I'm going to go ahead and erase these other two projected lines. just to clean things up. And again, you don't have to label that line. You can if you want to, if it helps you remember what it is. But the big thing is, as soon as I draw my hinge in perpendicular to this, I'm going to erase this, because what I don't want to do is I don't want to come back and think that this is my intersecting line and try to trim to it. So this is just strictly to help me create the next view. So I'm going to create a hinge perpendicular to this strike line. Maybe lengthen it out a little bit. And of course label, but in the interest of time, I'm going to keep on going here. And then project, and again, you can do one at a time. I don't think I would do all 5 at the same time, but I'm going to do all my plain ones at the same time. I think I can keep 3 separated. So there's my A, B, and C. So it looks like in order B is the closest, then A, then C. So B, A, and C. And once more, this is an edge view, so they should all line up. So there's my B point, there's my A point, there's my C point. And then I'm going to draw a line from the first point to the last point, and if all goes well, that middle point should be sitting perfectly on that line. Yes. What's up, Hugo?
Would you make that hinge perpendicular or parallel to?
Perpendicular to the true length strike line. Yeah, perpendicular to that true length strike line.
I tried that. Mine doesn't look like your true length. How do you get to the true length point?
So you, in the front view, create a horizontal line, and really just because this is parallel to this horizontal hinge, and then that way I can project up with a ray, and then where that hits BC, that will give me my other point. And again, we talked before, I could draw any number of horizontal lines in the front view, and it's still going to be parallel to this one. I just like starting on this corner because then I don't have to project point A, I just have to project this one point. So Hugo, to your question about going parallel, that would be the next step. If I asked you to find the true shape of the plane, then you're going to go parallel to this edge view. And that would be the true shape. But we're not going to solve for true shape on this one. This is all we need is the edge view. All right. Now I should go ahead and label, but in the interest of time, I'm going to keep moving and go ahead and project my Y and Z over. So there's Z, there's Y. Offset Z is my close one, Y is the further one. So that would be the line. And as I mentioned a while ago, I do want to get rid of this line because I don't want to mistake it for the intersection. You'll see that when I do draw my intersection back, it's pretty close to that one. So I forgot this time, but as soon as I draw this hinge, I usually go ahead and erase this line so that I don't get confused and use that as the intersection point. Turn these all to objects so they show up a little better. All right, so now I've got my intersection line, so I'm going to take that intersection and project back perpendicular to the hinge. Now, you don't have to actually put a point there, and in fact, what I wouldn't recommend that you know, a lot of times we'll put in a point and then we'll erase the ray. But I need that line there to act as a cutting edge. So I'm going to go ahead and leave that there for now. And I'm not even going to put a point there. You don't have to. But that's going to be my intersection. And then I can project that down, but I don't want to get too confusing yet. So I'm going to go ahead and solve this one before I project down. So this is going to be my intersection point. And I've got to decide, am I keeping this portion of the line or am I keeping this portion of the line? So I'm going to take a ray either from this intersection or this one. I'll start with this one right here. So I'll take a ray from here straight into the next view, and it could also be this direction. It could be into the next view that way as well. So it's going to hit the plane first, it looks like, but I'll take it straight down. So does it hit edge AB of the plane first or YZ? AB. So that means the plane is on top in this view where I started my ray, in between that edge and the intersection point. So I'm going to go ahead and trim out this point. And when you guys trim, another little shortcut, if you choose the trim command and just press enter to accept everything as a cutting edge, then you can jump straight to clicking on the part you want to get rid of. You don't have to specify your cutting edges every time. So then I'll erase these couple of construction lines, draw another ray down. That's going to show me my intersection point here. And then again, to figure out what's on top in this view, I'm going to start a ray maybe between AC and YZ. As it comes up, hits the plane first, but that's not the edge we want to know about, is it? No. So we're going to ignore that. Now granted, I trimmed this line out, but it would hit this line before it would hit AC. So since it hits the line first, the line is on top here, which means I trim out the opposite side. So trim and enter, and then I can click on that part to get rid of it. And again, you don't have to do this, but just to double check, I'm going to take this intersection over. I would expect it to run into the plane first, right? Since I just trimmed this side, I would expect it to hit BC before it hits YZ. As I come up, sure enough, it hits BC. So I know that's correct. So it doesn't hurt to double check yourself. You don't have to. So another example here, and if you guys just want to observe, I'll do this one real quick for you guys just to hopefully make sure you guys understand. So in this particular one, I've got a true length line. DE is parallel to the horizontal plane, so DE is true length here. So that's what I am going to draw my hinge perpendicular to. And again, for this one, I'm just going to throw in a bunch of shortcuts and do this real quick. So I want to bring E, D, and F across. I'm expecting a point view. Of course, those line up because I made them perpendicular to that. Offset with the current layer. I haven't done that yet. So D and E are the same distance apart. That's what's going to give me my point view for that one. And then F. So this would be my edge view of my plane. And as always, I should label, but in the interest of time, I'm going to jump to W and X. So there's W, there's X, and then my offsets down below. X, whoops, X is the close one, W is the far one. Which means it looks a little something like that. All right, so now that I've got that, I can take that intersection back. There's my intersection point, and now I just need to figure out what's on top. So if I start a ray maybe at this intersection, does it hit ED or WX first? Come down, looks like it hits ED first, so that means the plane is on top on this side of the intersection. So I'll trim out that part. Again, I don't have to do this, but I'm going to double check myself as I take this down. I would expect it to hit the line WX first because I've shown that the line is on top, and as you can see, it does just that. So now I just need to solve my front view, so I'm going to take this intersection point down and then take one of these two apparent intersections up. DF versus WX, it hits DF first, so that means the plane's on top. So I'll trim out that part. And again, just for the heck of it, I expect it'll run into XW before it hits ED. As I take a look, hits the plane first, but that's EF, I don't care about that. It hits the line before it hits ED, so the line is on top on this side. So if you take a look at the bottom two, this is the same exact problem, but we're going to use the cutting plane method, the much quicker method on these two. And the results should look identical. So once more, I'm going to use my join command to join these lines into one. And again, the idea with the cutting plane method is we're pretending that this is not a line, it's actually an edge view of another plane, which means I can project these intersecting points here. So I'm just going to take a ray from here down. And you could start in the top view or you can start in the front view, it doesn't really matter. And then this intersects line AB, so I'm going to come down to AB and pick up that intersection. This intersected with AC. So that'll take me down to AC here. And that now gives me my intersection point. Then once more, I'm just going to solve for visibility. AC versus YZ, it hits YZ first, so the line's on top, so I trim out the opposite side. And I'm typing TR and enter to get into my trim command quickly in case you're wondering how I'm doing that so quick. Then again, I can take a ray straight up. There's my intersecting line, and then solve for visibility. Does it hit AB or YZ first? It hits AB, so the plane's on top on this side. And as you can see, it should be identical to the one up top. I'll do one more over here. Since it's the quick, easy method, I'll join these guys together. Again, I just type J and enter. I don't really like hitting the modify button. I like the shortcut. Then again, I'll just take these intersections and project down, or take the ones in the front, project up, doesn't matter. So this is ED, this side's EF. So that is going to be my intersection line. So then once more, I'll take a ray up. Does it hit ED or XW first? It hits XW first, so the line's on top. So I trim out the opposite side. And then using a ray, I'll project that, maybe, project that up. There's my intersection point. And again, another ray. Does this one hit XW or ED first? It hits ED first, so that means the plane is on top on this side. So again, if I take a look at the one up above, it should be identical. There's two different ways to come up with the same thing. Now I think, have a solutions layer in here, if I remember correctly. No? I guess I don't.
There's another file.
That's what I did. I saved it as another file. Was it a template or a DWG file? I don't remember. It's probably a DWG file. Yes, it's a DWG in that same folder, intersection practice solution. And it has the examples in there as well. Looks like I went that way. Doesn't matter. Where we got room for? I'm sorry, plane? Yeah, intersection practice solution, but it's a DWG file. There you go. All right, so the plan for today is I'd like you guys to do the first two intersections. Let's take a look at them. Intersection 1, you are to use the more lengthy edge view method. So as you can see on the first example, you've already got an edge view. Plane MNOP is already an edge view, so you can project the intersection and then solve for visibility. Plane ABC here, you're going to have to solve for edge view, but you've already got a true length line. BC is parallel to the horizontal plane, so BC is true length here, so you create a hinge perpendicular to that to find your intersection. And then the last one, there are no edges that are true length, so you're going to have to create a strike line maybe in the front view and project that up to find your true length strike line. And then find your edge view and your intersections. So any questions what I'm asking for on the first one? All right. The second one should go pretty quick because it is the easier method. It is the cutting plane method. So just like that last exercise, simply project the intersecting edges, find your pierce point, and then solve for visibility. So this one, you shouldn't have to create any additional views. You've already got what we're pretending to be the edge view of another plane. So that one should go fairly quickly. All right, and that's all we're going to do today, just those two. So let me know when you guys have any questions.